We're going to start by looking at the syllabus for paper 1 for the Cambridge board, and we're going to go through point by point each element that is required of the syllabus, look through problems and examples, and obviously ask questions as we go along the way. So looking at point number 1.1, we're looking at quadratics, and the first bit of it says carry out the process of completing the square for a quadratic polynomial. And then in the notes and examples, it says that you need to locate the vertex of the graph in order to be able to sketch the graph. So let's have a look at what completing the square is. So completing the square is another way of rewriting a quadratic equation. Now a quadratic equation looks like something like this, ax squared plus bx plus c. So anything that has a highest order of x squared in an equation will be a quadratic equation. This here, a, b, and c, are just constants, so don't ever worry about what they are. They're just arbitrary numbers, which we don't panic about. Now, when we're completing the square, we are asked to rewrite this in something that looks like x plus or minus plus b. So you can have plus or minus a squared plus b. Now, this is a perfect square here, so the idea is that we rewrite a quadratic as a perfect square, and this little bit here is just whatever's left over. Okay, so not every quadratic factorizes to a perfect square, but that's what we're trying to do, but not ignoring the leftover bits. We're still rewriting the leftover number here at the end. So why are we completing the square? Two reasons really. We can solve for a quadratic equation for x by completing the square, and I'll show you how. And then also you can find the vertex, which I'll also show you how. So vertex is the minimum or maximum number. And the third reason could be that you're just doing it for fun, which it is. So we're just going to rewrite this in a different form. Okay, I'm going to start with a very simple example of a quadratic equation, and I'll teach you step by step how to complete the square on it, and then we'll take it up a level, and then we will do some examples from the exam questions. So the first one, if we have a look, I'm going to pick a really simple one, x squared plus 4x plus 3. This is my quadratic equation, and remember that I want to rewrite it like this. Don't worry about the plus, that could be a plus or a minus. Could be any sign in there. Okay, so the process of completing the square on this, we want to rewrite this in a perfect square, and then we can have some leftover number if it doesn't naturally factorize into a perfect square. Right, so here's the process. The x here, x squared, rather than x squared, it'll just be x because you're squaring it outside. This sign here will always be whatever's in the quadratic. So if this was a minus, you just bring the minus down. If it's a plus, you keep it as a plus. And then here's the bit where we do a little bit of math. So you always take half of this number. Okay, so just the number, not the x. So whatever that number is, if it's 4 or 6 or whatever, you just divide it by 2. So in this case, that would be 2. Leave that square there, so that's the perfect square created. In order to take over any leftover bits, you always minus, okay? So this, I'll just write it here. This is always a minus when you're completing the square. And then you always take this number, 2 squared. So you're almost cancelling it out as a number at the end. So you subtract that, and then whatever number you have left, you just put it there, so plus 3. And that's completed the square, really. All we have to do is tidy it up. So let me just go over this again. You always take the x as the x, bring it down. Whatever this sign is will go down as whatever the sign was. You take half of that number, and then you always take away that number. So whatever number you have here, you'll have out here, okay, squared. So you always take away. And then if you have any leftover number, you just write it on the outside. Okay, so let's tidy this up. This becomes x plus 2 all squared minus 4 plus 3 to give you x plus 2 all squared minus 1. And we've completed the square. So we've rewritten x squared plus 4x plus 3 in this form. Okay, now remember, we haven't mathematically changed this at all. We've just rewritten it. Okay, now why do we do it? Two things, like I said. Firstly, you can solve it. So if someone asked you to solve it, x squared plus 4x plus 3 equals to 0, which solving means that find the x value, you can complete the square in it, which we already have done. So I've got x plus 2 all squared minus 1 equal it to 0. And then to solve it, all you have to do is work out your x value. So I can move that minus 1 to the other side. I've got x plus 2 squared equals to 1. Now get rid of the squared, square root to the other side. I've got x plus 2 equals to square root of 1, which is just 1. And then you've got x plus 2. Let's just do it again. Equals to plus minus 1 to be more correct. And then you can take the 2 over, so you've got x equals to plus 1 minus 2, or x equals to minus 1 minus 2. So you'll get two answers. From here, you'll get minus 1 or minus 3. And those are your solutions, okay? So those could have been the solutions when you factorize it. So that's when we use completing the square to solve. We can also use completing the square to find the vertex. Now, firstly, let me just tell you what a vertex is. So a vertex is when you have a quadratic equation. So say if I have an x squared, whatever, quadratic equation, this is a positive quadratic equation. So a positive curve will look like that. And the vertex is this value here. So I'll have some value x, y, and that is your vertex. If it was a minus x squared, whatever the rest of the quadratic equation, it would be a negative one. And here you will have the vertex. Now in this case, this vertex is a minimum value. And in this case, the vertex is a maximum value, as you can see, because it's at the top. Right, how do you read the vertex onto here? So you've got our equation, which is x plus 2 squared minus 1. And the vertex is just kind of transformations, which we'll do later. But the vertex are just those two coordinates. The plus 2 will become your minus 2 for your x value, and the y value stays the same. So essentially, you change sign for x, and the y stays the same. So for this particular graph, x squared plus 4x plus 3, let's do that here, x squared plus 4x plus 3. First of all, I know that it's a positive x squared, so I know that the shape of the graph will look like that. It will be a positive. And then I've worked out that its vertex is at minus 2, minus 1. So here, this value here is going to be minus 2, minus 1, which we have just worked out. So it would be, let's just see if I can draw it correctly, minus 2y and minus x, something like that if I put the xy axis there. So my vertex is going to be x is minus 2 and y is minus 1 here. So I found the minimum value. And that's where we complete the square in summary. I'll do another example just with a number or so outside, and then we'll do some exam questions. So if I pick another one, let's pick a slightly harder one. Let's put a number next to the x. So 2x squared plus 10x minus 11. Right, completing the square in this. Now you see that there's a slight problem. We've got this 2 on the outside, which I'm not happy about. But if you're ever unsure about these kinds of things, we can just take it out of the equation. So I'm going to take the 2 out of these two terms. It doesn't matter if it's a common factor or not, you can just take it out. So I'm left with 2x squared plus 5x here, and then I've got minus 11. Okay, now that I've done that, this looks easier, like the kind of thing I'm used to, and I'm going to complete the square on this. So just ignore all of these numbers around. Ignore this, ignore this. We're going to keep it, but just don't let that bother you. Leave the 2 there. I'm going to complete the square on this. So remember what I said, bring the x down. The sign stays as it is. Half of this number, so half of 5 over 2 is 2.5. Sorry, half of 5 is 2.5, or 5 over 2 squared. Always take away whatever number you have there. So that's 5 over 2 squared. And that's that part done. And then you have this minus 11 on the outside. Okay, right. Let's sort it out. Let's tidy this up. I've got x plus 5 over 2 squared. Square that. That gives me 25 over 4. And then the minus 11 is still on the outside. Now, you can bring this 2 into here, times it with that bracket, and times it with that. So I have 2x plus 5 over 2 all squared. Multiply the 2 with the 25 over 4. So that's just going to half it. So I've got 25 over 2, and then I've got minus 11. I've got to add these two numbers together. So I've got 2x plus 5 over 2 squared. I'm going to add these so I can take 2 as my common factor, 25. So I've got to double this by 2 to give me minus 22. Oh, got stuck there. And now if we tidy this up, I've got x plus 5 over 2 all squared minus 47 over 2. And that's your completed the square answer. So From here, if someone asked me for the vertex, I would just take this and this. These are my coordinates. Remember to change the sign of your x, so that becomes minus 5 over 2 minus 47 over 2. And that's completing the square. Shortly, in the next clip, I will do some exam questions from the Cambridge board and from a few other boards. Any questions, feel free to ask.